Hello everyone, welcome back to Global Math Mentor. In our last lesson, we explored how to find the maximum or minimum value of a quadratic function using two powerful tools, completing the square and differentiation. That gave us the strong foundation for understanding the turning point of a parabola, like what we call the vertex. So this is what this lesson is all about. Use the maximum or minimum value of f of x to sketch the graph of f of x or determine the range for the given domain. So today we're going to build on that learning how to find the range of a quadratic function when you're given a specific domain. This is super important for solving real world problems and mastering function behavior on different intervals. Let's dive in and see how the vertex endpoint help us unlock the range. So for those who are really new to this idea, range, simply speaking, if this is, let's say, I'm just making a funny person, okay? So if this is you, let's say, the range is like a height of the function. How high this is the range, okay? And the domain is how horizontally stretched anything is. That's the domain. These are the mathematical words for inputs and outputs. The domain are x values, the inputs, and the range are the outputs, the y values. Okay. But in mathematics, we use range and domain, these words. Since we are dealing with quadratic functions, so I'm going to take a quadratic function example. Let's begin with, let's say, f of x is x squared minus 4x. And I'm assigning a domain, x belongs to R. If you're familiar with set notation, this means that x is the member of all real numbers. So x can take any real value, right? This can also be written as like what they mean by candidates should use correct notation. Sometimes you can write it like in inequality notation as well, or this is the same thing, negative infinity to infinity. But the additional mathematics course does not restrict to right interval notation. So you can use either inequalities or set notation. It's up to you. So how do you find range? Whether the question is about range, you have to find the vertex, the coordinates of the turning point first. You have to see where it falls. So this is not a restricted domain, it's an open domain, but I'll get to a restricted domain example, the next one, so you can see whether your turning point falls within the given interval or not. This is an easy case, like an open domain. Okay, so I'm going to write this as a complete square form just to get the vertex. However, I can use other methods as well. Okay, I'll give you a couple of more ways of getting the vertex. So way one, let's say way one. So you can write this as half the coefficient of x, which is 4, half it, 2 squared, added, and subtracted. So by now, I believe you are familiar with this idea that why this is x minus 2 whole squared and minus 4. So using your complete square form, the x coordinate of the vertex is going to be a 2, and the y coordinate is going to be a negative 4. What is way 2 of getting the vertex? Just like we did earlier, differentiation, f prime x is going to be 2x minus 4, put it equal to 0, and this will give you x equals to 2. And similarly, you can get the y value by substituting this x back in the given function, okay, which is a negative 4. All right, so I haven't talked about this earlier, but way 3, guys, this is like a really cool trick to find the x coordinate of the vertex of a parabola. So it's known as a shortcut method. The x coordinate of the vertex can be found just straight away, minus b over 2a. All right, let's see how cool this is. If you check the initial function, a is a 1, b is a negative 4, and c in this case is a 0. So let's try whether this gives the same x coordinate, which is a 2, minus 4, which is a b value, divided by 2 times 1. Well, there you go. It gives you the correct answer. So just box it somewhere, highlight it. This is another way of finding the x coordinate of the vertex. Okay. So each of these cases, you can get your x coordinate and y coordinate. So that's step one while determining the range of a given function. Okay. So -4, that's the vertex. Now, step two, how do you identify range? You need to sketch this function. So I'm going to be sketching it right here. There is no restriction on the x-axis. X can take any value. So I'm going to put a 2 and a -4. It's just a sketch. Remember, like 2 and a -4. Okay. What is the y-intercept? Y-intercept, your function is x squared minus 4x. So if you substitute x equals 0, the y value is going to be 0 as well. So my graph will intersect the y-axis at 0, 0. So let's hope I make a good parabola. It should look something like this. Okay. All right. So that's my graph. Now try to identify what is the minimum, that like the least possible value of y. The least possible value of y is going to be a -4, which is the minimum value of the function. And up, we have no end to that, right? So how do you write your answer? Let's write the answer. Your range, one way of writing is the simpler way is y greater than equal to a -4. Or you can write, don't get confused by these ors that I put. I'm just giving you more variations to write the same answer. Okay. This is another way. Or you can write it like the function has a least value of a -4 and the greatest value is unknown, which is like a huge number. That is infinity. This is an optional one, students. That's an optional one for additional mathematics, but you can give an interval notation to it as well. Since -4 is included, so you will put a square bracket, a -4, comma, and since this number, the infinity, which is like a huge number, it's an unreachable number, so you put a parentheses over here. This is another way of writing the range interval of this function. Okay, let's take another example. So I'm going to be writing like a slightly harder example. So f of x, let's say if the quadratic function is 6 minus x squared, right? And I'm going to be assigning like a restricted domain this time. What do I mean by restricted domain? Let's say x is within -3 and a 1. So this time it's not all real number. How do you identify range in this situation? Let's go. Find range. That's the question. Obviously for this given domain, the domain which is given in the initial question. Okay. So I have to check whether my turning point of this parabola, which has a maximum turning point, does it fall in this interval or not? So for that, I need obviously the completing the square either or differentiation, or I can use a shortcut. You might be wondering, there is a reason I'm going to go with the completing the square this time. This is like a harder example to go with your classical completing the square method. So grab on your notebooks and make sure you don't miss this one. So first of all, the coefficient of x squared is a -1. I need to factorize it to make it 1. So when I factorize from the first two, like the x terms, is going to be plus x, okay, and plus 6, as I told you earlier, I don't worry about this number. All I'm interested in is these x squared and x values. Okay, I've factored it out. That's the first step. Now the coefficient of x is a 1. What's the half of 1? That's a half. So add a half squared and subtract a half squared, right? And plus a 6. Now these three values over here will form a perfect square, which is x plus a 1/2 whole squared. And -1/4, which was the balancing factor, it just goes straight away like that. Now expand the negative. This is going to be minus x plus a 1/2 squared plus a 1/4 and plus a 6. Finally, I can write my answer as x plus 1/2 squared plus 6 times 4 is a 24, add 1. So that's going to be a 25 divide 4, which is roughly 6 point something. But the reason I'm not using any calculator assistance this time is that Remember, guys, there's going to be a non-calculator exam for additional mathematics, 80 marks, and a calculator exam, which is also 80 marks. So you got to be good with your non-calculator calculations. What is the vertex? Let's go. It's going to be a negative 1/2 and a 25 divide 4. That's the y coordinate. Well, it does. My vertex does fall within this domain. Okay, so it needs to be checked in every time you're trying to find the range of a quadratic function. Okay, so let's sketch it. So my domain is -3 to 1. This is the x-axis and the y-axis. So -3 and a +1. Obviously, since it's a restricted domain, I need to check my values on this -3 and +1. Okay, I'm going to check those. F of x is 6 minus x squared. Let's try and find what is f of -3. It's going to be 6 plus a 3 and minus a +9. So this becomes a 0. So I know that -3 gives me a 0. -3 and a 0. Okay, now it's time to check what does the function behaves when x is 1. How does the function behaves when x is 1? This is going to be 6 minus 1 minus 1, which is a +4. So 1 gives me a +4. So my -1/2 and 6 point something. So look at this thing. I'm going to use a different color pen. This is what the parabola will most probably look like. Okay. So it's just a sketch, remember, right? I can make it slightly clumsy. It's all right. It's all right. Okay, so the turning, okay, and that's it. This is the vertex I've mentioned over there. That's the vertex. If you are interested to find the y-intercept, so I'm gonna put the y-intercept as well, which is if you check again, look at this function carefully. If you substitute x to be 0, your y value is going to be a 6. So there we go, 0 and 6. That's the y-intercept. But that was not required for the range. In a range, all I'm interested in is the maximum possible value of y and the minimum possible value of y, which is a 0. I hope you understand. Let me just highlight it once again. This is how the function behaves within -3 and a 1. Okay. So it does sounds like it's a very lengthy trick, but once you are in good form and you're practicing regularly, this won't take that much time. Let's write the answer, guys. Answer is for the range. The maximum possible value is 25 divide 4, and the minimum possible value is a 0. Okay, that's the answer. Range. Range is how high and low the function is. Domain is how horizontally spread a function is. All right. All right, here we go. So I'm going to be solving 3 problems, and each problem I will find the minimum point using a different method. All right. If you want to solve them on your own, maybe you can pause the video and try them, right? Okay, so watch my solution now. Find the range of this for all real numbers. Obviously, I need the turning point, the vertex. So first part, I'm going to be using differentiation to quickly get the vertex. dy by dx is going to be 2x minus a 4. Put it equal to 0, and 2x will be a 4, and x is going to be 2. Let's get the y value. Y will be a 2 squared minus a 4 times 2. In place of x, you can substitute 2 and plus a 3. So y is going to be 4 minus 8 plus 3. This is 7. That's a -1. Okay. So the vertex is 2 and -1. And the y-intercept of the graph is going to be c equals to 3, right? Let's just quickly sketch. It will be a parabola upward open with a minimum turning point 2, -1, and something like this. Okay, that's the sketch. 3, and this is a 2 and a -1. Okay, so what is the minimum possible value? The minimum possible value of y is a -1. So remember, inequality will be required because you have to find the range. Domain is all real number. Okay. So the range is going to be all values greater than or equal to -1. Or you can write it as, don't get confused by these ors that I put. So I'm just giving you like some variations to your answer. Okay, that's the first one. Problem 2. Find the range y equals to -x squared plus 6x minus 8 with the restricted domain. This time there's a restricted domain, and the parabola that we're going to be sketching to get the range is with a maximum turning point, since the coefficient of x squared is a -1. Okay, so this one I'm going to be using the completing the square form. Okay, so factorize, take out the negative, and this is how you can write it. Okay. Now this is going to be minus, do that thing the same that we've learned, 6x, half the 6, that's a 3, add and subtract it square, minus 8. This is going to be x minus 3 whole squared, minus 9, and minus 8. Guys, make sure you go over these steps. So it's important if you want error-free working, 9 minus 8. So I can write it either as minus x minus 3 squared plus a 1, or sometimes they might ask you to give your answer like this. So it's the same thing, doesn't matter. What are the coordinates of the vertex? 3 and 1, and this is a max point, right? Let's just sketch it. And it's not just all real numbers, so keep in mind that you need 2 more values. So let's say if your function is minus x squared plus 6x minus 8, find these f of 2's and f of 5, right? You can use a calculator as well, but if it's a non-calculator paper, 2 squared plus 6 times 2 and minus 8, which is going to be -4 plus 12 minus 8. That's 0. Okay, and what about the next one? It's going to be -5 squared plus 6 times 5 minus 8. It's going to be -25 plus 30 minus 8. So that's +5 minus that's a -3. Yeah. So we have these values. Now, how do you sketch it? It's restricted. It's from +2 to a 5. So this one, the y-intercept is going to be a -8. So this is what my graph will, oh, wait. So 2 gives me a 0, which is like the graph is going to pass from here all the way. Oh, my God. Wait, let's say this, and it goes like this. So on 5, it gives me a -3. On 2, it gives me a 0. And this is a -8. But this is the crucial part. You need to check what is the minimum possible y value in all of this when your graph is stretched from like this, from 2 to 5. What is the minimum and the maximum value? So, okay, 2 gives me a 0. So here the y value is a 0. What is the maximum value of y? Okay, that's going to be, because since the coordinate of the vertex are 3 and 1, okay? So I'm going to be using y equals to 1, right? 3 and 1. Look at this, 3 and 1. And this is y equals to -3. So during this 2 to 5, the minimum y is a -3 and the maximum y, this is the shape of the graph. You can highlight it this way because this is the shape of the graph, okay? So my range is going to be answer. Let me just write it with the f of x. The maximum value is going to be a +1, and the minimum function value is going to be a -3, right? I hope you understand this. If there are any confusion, make sure you comment, and I'll try my best to answer you as soon as possible, right? So final example, find the range of y equals to 2x squared minus 8x plus 5 with the restricted domain 0 to 4. So for the last example, I'm going to be using the shortcut method, right? What's the shortcut method? Just rewind and watch the trick that I gave you to find the x-coordinate of the turning point. That's going to be a minus b over 2a, right? Because vertex is actually what we need. So whenever there's a quadratic function question, so make sure you always get the vertex whenever there's a range question. Okay, so this is going to be a negative minus 8, because b is a negative 8, over 2 times a. It's going to be 8 divided 4. So that's a positive 2. Let's get the y value. So 2 times 2 squared minus 8 times 2 and plus a 5. It's going to be 4 twice 8 minus 16 plus 5. So this is going to be a negative 8 and negative 3, right? So 2 negative 3 is the coordinate of the vertex, right? And now I need to check when x is 0, what is y? Y is going to be a 5. When x is a 4, what is y? 2 times 4 squared minus 8 times a 4. I'm substituting x back in the given value, given function. So 16 double is a 32, minus 8 4 is a 32, plus 5. So we just get a positive 5, right? So let's sketch it now to get the range. I usually prefer the sketch because that can help you better understand the shape of the graph. This is a minimum 1. The turning point is a minimum 2 and a negative 3. Okay, when x is 0, y is 5. So it's like this. So the graph goes something like, oh, my bad. Okay, something like this and all the way till this, right? Okay, so 4 gives you a 5 and 0 gives you a 5. And what about the minimum point, 2 and negative 3? All right, can you quickly guess what is the range? Okay, if you have, that's wonderful. But if you haven't, just take a look at it and keep practicing till you master the skill. Function's maximum value, the y value is going to be a 5, and the minimum y value is going to be a negative 3. Take a look at this, guys. That's the maximum y value. That's the minimum y value. So this is the range of the function. All right. So that's the wrap up for today's lesson. We've seen how the maximum and the minimum value of the quadratic function helps us sketch the graph and determine its range when the domain is given, right? So in the next video, we'll move on to solving simultaneous equations where one is a linear and the other is a quadratic one. This will help us find points where the line and the curve meet, which is a key skill in algebra and graphing. Until then, keep practicing and see you in the next video. Over and out.